Hey there, so you want to learn the powerful and versatile Java programming language, but you're not quite sure where to start? Well, you've come to the right place. This is your roadmap, and it's going to take you from curious beginner to a capable builder. Let's jump right in. From the Android apps that are probably on your phone right now to the massive, complex systems that run banks and businesses, Java is literally everywhere. So this isn't just about learning to write code, it's about getting the power to create real, tangible things that people use. Let's get you on that path. Okay, here's our game plan. First, we'll talk about why you'd even choose Java. Then, we'll get your tools set up. After that, we'll dive into the absolute must-know core concepts, and then we'll get into the right mindset for thinking in Java. And of course, we'll talk about practice, and finally, I'll give you a whole toolkit of resources for the journey ahead. So, first things first, out of all the programming languages out there, why focus on Java? What's the big deal? I mean, it's kind of mind-blowing when you think about it. Java is this rock-solid language that big companies trust for their most critical systems. It's the engine behind countless websites and web services. And if you've ever thought about making an Android app, well, Java's where it all started. Learning it really does open up a ton of doors. All right, every builder needs a workshop. And for a programmer, that means getting your software environment ready to go. This is a super important first step, and trust me, it's way easier than it sounds. You really only need two key things to get started. First is the JDK, the Java Development Kit. Think of this as the engine. It's what actually compiles your code and makes it run. Second, you need an IDE, or Integrated Development Environment. This is like your high-tech workbench. An IDE like IntelliJ or Eclipse is a brilliant code editor that helps you write, test, and fix your code so much faster. Okay, workshop's all set up. Now it's time to actually start building. We're going to break down the absolute fundamental building blocks of Java, starting with the very basics. First up, let's talk about variables. The easiest way to picture these, they're just labeled boxes. You have a box labeled age that can only hold numbers. You've got another box labeled name that can only hold text. In the world of programming, these boxes are called variables. And the rule about what kind of stuff can go inside, that's its data type. And this example right here shows that perfectly. When you write int userAge equals 25, you're just telling the computer, hey, make me a box that holds whole numbers, call it userAge, and stick the number 25 inside. Then, with string username equals Alex, you're saying, now make a box for text, call it username, and put Alex in there. See? It's that straightforward. So, we can store data. But how do we get our program to think or make decisions? Well, that's where control flow comes in. Picture it like a traffic controller for your code. An if statement asks a question like, is the user's age over 18? And sends the program down one path or another. And loops, they just repeat a set of instructions over and over again, like checking off every item on a list. Now, what happens when you need to store a bunch of items? You use something called a collection. Two of the most common ones you'll use all the time are array lists and hash maps. An array list is exactly what it sounds like, a simple, ordered list, just like a grocery list. A hash map, on the other hand, is more like a phone book. You use a key, like a person's name, to instantly look up its value, like their phone number. Okay, let's step it up a notch. We're going to move on to a really powerful way of thinking. Java is an object-oriented language, which is just a fancy way of saying it organizes code to model things in the real world. We're going to quickly break down its four main ideas, or pillars. The first pillar is encapsulation. This might sound complicated, but the idea is actually super simple. It's all about grouping related things together. You take some data, like a car's color and its current speed, and the actions related to that data, like accelerate or brake, and you bundle them all up into one neat little package called a class. This is the perfect way to think about it. The plastic shell of that capsule keeps the medicine inside safe and sound. In the same way, encapsulation protects your data from being messed with by accident. You can only interact with it using the methods you've defined, which makes your code so much safer and more predictable. The other three pillars build right on top of that. There's inheritance, which lets us reuse code. You can make a general vehicle class, and then a car class can inherit all its properties. Then you've got polymorphism, a fancy word that just means many forms. It lets different objects respond to the same command in their own way. And finally, abstraction. This is all about simplicity. You don't need to know how a car's engine works to drive it, right? You just need the steering wheel. Abstraction hides the complexity. Phew, okay, that was a lot of theory. But here is the single most important part of learning to code. You have to actually do it. This is where all that knowledge gets turned into a real skill. So where do you begin? Honestly, the best way is to build something simple, something tangible. Let's look at 3 classic starter projects that will make all of this theory finally click into place. You could build a basic calculator. It's a fantastic way to practice logic and handling user input. Or how about a to-do list that runs in the command line? You'll learn a ton about managing lists of data. A simple banking app is another amazing choice for practicing those object-oriented ideas we just talked about. You can create account objects with methods to deposit and withdraw. And here's a huge pro tip for you. As you build these projects, even the really simple ones, put them on GitHub. It's a website for hosting your code, and it basically becomes your live resume. It's proof that you don't just know the theory, you can actually build things. You know, nobody learns to code in a vacuum. So to wrap things up, let's look at some awesome resources that will help you solve problems and keep growing long after this is over. For a full, structured course, the University of Helsinki's MOOC is legendary. And get this? It's free. If you're more of a book person, Head First Java is famous for making tricky subjects really fun to learn. When you inevitably get stuck, communities like the r/LearnJava subreddit are amazing places to ask questions. And when you want to sharpen your problem-solving skills, websites like HackerRank are the place to be. But at the end of the day, this is the most important takeaway of all. Learning to code is a marathon, not a sprint. Practicing for a little bit every few days is so much better than cramming once a month. It's all about consistency. And this chart just says it all, doesn't it? Look at that. Passively learning, reading and watching videos, that's just a small piece of the pie. The vast majority of your growth, the real deep learning, comes from actually building projects and practicing your skills. That's where the magic happens. So there you have it. That's your step-by-step guide to getting started with Java. You have the map, you know the tools, and you've seen the core ideas. The only question left is, what are you going to build first?